Determine two ways to restrict the domain of this parabola, and they've drawn the parabola for us. I am going to take the time to label the vertex is at 1, 3. Determine two ways to restrict the domain so that its inverse is a function. Write an equation of the inverse each time and use a graph to illustrate each way. Okay? First of all, can you see that the parabola right now doesn't pass the horizontal line test? So technically, if we did the inverse will not be a function. Okay? So what we have to do is we have to restrict the domain. So let's see, what kind of space do you have? I think you have enough space. Okay? Carefully write two ways and split your page perfectly in half. Okay? This will be the first way. This will be the second way. And we'll do the whole question for each one. Okay? When you restrict the domain, what that means is you're going to only take part of the graph. And the way that we're going to restrict the domain is we're going to use the vertex and take the x values on one side of the vertex and the x values on the other side of the vertex. For example, so my vertex is at x equals 1. If I take the left side, then my restricted domain is x is left side less than or equal to 1. And since I'll do this side in green, I'm going to draw it on here on green. That would be that side only. Can you see that if you said I'm only taking the x values less than or equal to 1, I only have that half of the parabola. If I only have half of a parabola, does it now pass the horizontal line test? Yes. Okay. So the question is saying, determine two ways to restrict the domain. We found one of them. For method number 2, which I'll do in purple, we would take this half when x is bigger than 1. Bigger than or equal to 1. There we go. So you could either take the left half or you could take the right half. Write an equation for the inverse both times and draw a graph to illustrate both ways. I actually think the graph part is the easier part, so we'll do that first, and then I'll give you two options for figuring out the equation. Okay? So we're going to do the graph next. So for the green one, I wanted to do the graph of the green one. What I'm going to need is points on my green graph. You see that you have 1, 3. On your green graph, you would also have 0, 4, and it looks like 1, 7. What do we do with an inverse? All we have to do is switch x and y. So on my green one, if I switch x and y, I'm going to have 3, 1. I'm going to have 4, 0. And I'm going to have 7, -1. there's my graph. Okay? Now the options for the equation. To find the equation of the inverse, we could do it algebraically, or we could figure it out from the graph. If we were doing it algebraically, we would do the following. We would switch x and y. So instead of y equals, I have x equals, it was y minus 1 squared plus 3, and then I would have to get y by itself. How would I do that? I bring the 3 over to the other side, so I would basically get the y minus 1 squared by itself would equal x minus 3. I would square root both sides. When you square root both sides, you have to remember plus or minus. And finally, add 1 to both sides. And I'm going to put that plus 1 when I add it at the end, so I can think about transformations. And what we have to decide for the green graph, does the green graph have the plus out front or the minus out front? Which one will it have? The minus. And could you tell because of the graph? Because a regular square root had to get flipped vertically to go down. So it's one of the reasons I did the graph first. This one has the minus. So we have to decide whether it's plus or minus in front. The plus, if we have a minus in front, that would be a vertical reflection. So if we think of a regular square root graph, and I'll just temporarily, yeah, I think it works. This is a regular square root graph, right? It would have to reflect down in order to get this shape. Right? Because the negative outside, we start with this, right? The negative outside would flip it down. Then we have a 3, moving it 3 to the right. And finally, we have a plus 1, moving it up. And that matches with our graph. Okay? Now, some people can get the equation just by looking at the graph. They'd be like, okay, I need to flip. I need to move 3 to the right and 1 up. And my 3 points that are right here still match up with my parent graph, so I know there's no stretches or compressions. That's sometimes a little bit more difficult to see all of that. So the equation is nice that way. Now we're going to do the same thing in purple. For x greater than 1. We're going to graph it first. We're going to look at our original graph and say, what are some points I can label on here? I know we have 2, 4, and 3, 7. Those are all on the purple side of the original graph. So when I go to graph the purple side, I still have 3, 1. But I will now have 4, 2 and 7, 3. And it's the top half of that sideways parabola. Because we've already switched the x and the y, and we've done that work already, the equation for the top part is going to be the positive one. You don't have to write that positive out, but I'm just going to do an extra emphasis there. by saying this time I'm taking the plus side. It was still the square root graph, moved 3 to the right, and then shifted up 1. But we got that equation from the other one. Okay? Some other things that sometimes become helpful for figuring out which one is which. Okay? The key thing with inverses is x's and y's get switched. So if you restrict the domain of the original function to be x less than or equal to 1, this also means that the inverse would have a restricted range of y less than or equal to 1. Do you see that on our graph? That the y values go down from 1 as a restriction. Anytime your range is going down, you will know that your square root needs the negative. This one would have a restricted range of y bigger than or equal to 1. That would have to be a positive square root. So there's a couple of ways to determine, because every time you do the equation algebraically, you're going to get the plus or minus, and you have to decide which one goes with which. Okay? You have a question like this on your test. With a little bit of thinking to do, they like to ask about the restricted domain. So far, on the 10 years of exams that have happened, they have never done something other than a parabola for this question. So far, it's always been the parabola, and to restrict your domain of the original function, you're always looking for the vertex. Of course, your vertex could move, but you always are going to restrict your domain based on the x coordinate, because you're going left side of it and right side of it of your vertex. All right, question for practice on this one are 10 and 12. Does anyone need me to scroll up or down? Yes, there were. Did I not say them? No. 5 and 6. 5 and 6 for question 2, 10 and 12 for this.